get it. Hold on.
I noticed collecting.
I am. Sorry, I'm gonna take my phone.
How we doing? How we doing? What's up, man? Back?
I'm back. I haven't been sleeping, so I slept in yesterday.
Just watch the video.
I did not. I need to.
Mr. Hurry,
It's unfortunate.
I got an email from school saying I got their honors program, but I didn't get, like, they haven't set out, like, decisions yet. Does that mean I've gotten to the school?
Most likely.
Okay.
Or that would be like the biggest psych ever. Welcome to the honors program. Denied. Yeah, I would think so.
Chapel Hill? Okay.
It's you, nice.
You got I think I did. I'm not sure. If you guys
All right, guys, so hopefully you are feeling okay about what we did yesterday. It's really easy, I think, to feel okay, and then when you're put on the spot to actually new, except show you maybe different ways the questions are asked. AP is really table happy. They love to give you little charts, little tables, things like this, and ask you to do things with them. I look at it as a gift, because I don't know about you guys, but I didn't like plugging in 4 into x squared minus 3x plus 5 yesterday. I would rather them just tell me what the y values are. So in a chart like this, they're giving you something about Roger deciding to run a marathon. They give you a bunch of times. They give you some speeds. And they're asking you to use what you know about integrals now to figure stuff out. Now, let's walk through this a little bit. What did we already learn this year about if I have a position equation and I take a derivative of it, I get a what? We did that, velocity. We did that at the end of last semester. So if you take a derivative of position, you get velocity. Well, what do you think happens if I have a velocity equation and I integrate it? I get back to position. Now, there's a little bit of a difference in that what I'm doing is I'm getting a change in my position. Now, a change in the position doesn't give me a location. Like, think about that for a second. If I tell you that my position changed 2 miles, do you know where I am located? No, because you don't know where I began. So make sure you get this. Or like, for instance, if I said, hey, the rate at which it's snowing is blah, blah, blah. If I integrate that rate at which it's snowing, what do you think I end up with? Let me actually set you up a little bit better than that.
The amount of snow and then
Yes,
variable
yes.
you don't know.
But let me set you up a little bit better. So like we know velocity is a rate at which we're moving, right? And when we integrate velocity, we get that position, right? Or we could say velocity is a rate at which the position is changing. So when we integrate that rate, we get the amount of the change, but I still don't know where I am. So if I had a function that described the rate at which snow was falling, and I integrated it, I would get what? The amount of snow that fell. So if I told you the amount of snow that fell was 22 inches, how much snow is on the ground?
How much do we start with?
Exactly. I don't know how much is on the ground. I just know how much additional snow fell. My sister lives in Flagstaff. She sent me a picture of her front yard, and the snow was like waist high. And she said, we're expecting 22 inches that day, like later on. So I don't know what it grew up to. I remember once she sent me a picture, her dog was on the roof. Like there was so much snow that her dog ran up the bank onto the roof and was barking at people as they plowed, came by in the snow plows and stuff like that. Yes.
I need a book, like the book. I never got it.
You needed the book.
The whole last chapter.
I mean, I didn't have the book. I didn't want to print out the whole thing.
Right.
Did you do well?
How'd that work out for you?
I mean, that doesn't mean I didn't learn anything.
Mr. Hurry seems really excited.
All right, man.
Thank you.
So, moving forward, better late than never, right? Okay, so I want you to understand that what we're doing when we integrate, a lot of times we're integrating rates of change, okay? Now, not always. Sometimes I'm integrating rates of change, like acceleration. But for the same way, when I integrate, when I take a derivative of something, I get the rate at which that function was changing. When I integrate something, I get back to not the amount that I have, but the change in the amount. And it's important that you make that clarification, okay, or that bit of understanding. So integrate a rate, you get a change in the amount. I may not know how much I have, but I know how much it's changed. Are you seeing that? Okay, so if I integrate a velocity, I'm going to get a change in my what?
Distance.
Distance traveled or change in position, right, which we call displacement, right? But I don't know where I'm located. I just know how far I am from where I was when I began. If I wanted to know where I was located, I'd have to know where I began, right? Then if I integrate the rate at which snow is falling, I'll know how much snow was accumulated, right? How much snow was there, but I don't know how much is on the ground because there might have been some before I started. Are y'all seeing that? Okay, so look at this equation from your homework last night, and I just want to walk you through it. So make sure that you're in good shape because we didn't get to do a chart problem, but I hope that you see that when we're finished that it's not as bad as it looks. So right here it says Roger's deciding to run a marathon. Roger's friend Jeff rides behind him on a bike and clocks his pace every 15 minutes. So every quarter hour, he's clocking his pace, okay? So 15 minutes, right here. So those are the times, and those are the speeds, okay? Now speed is kind of like velocity, except it's non-directional, right? When I say I'm going 50 miles an hour, it's not important that I'm going, oh, I'm going to the right 50. Whereas if I said velocity was 50, I would have to go to the right 50, because velocity could be negative. Are y'all with me so far?
Right.
Okay, so this gives me all the speeds of Roger based on his friend Jeff. Now the question is, the data Jeff collected is summarized below, assuming Roger's speed is always decreasing. And you can see that right here, 12, 11, 10, 10, 8, 7, 0. And the reason they said that is they don't want you to think, oh, it's 12, and then it's jumping up real high and then coming down. Basically, they're giving you some kind of a slope situation here. It says, blah, 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 hold on. Assuming Roger's speed is always decreasing, estimate the distance Roger ran in the first half hour, that would be to here, and over the entire race. And they want you to do that with the trapezoidal sum. Now think about it. If I want to know distance traveled, right, that's kind of like the change in the position that he had. And you know if you have a position equation, you take a derivative, you get velocity, which is like speed. Well, if I have a speed equation and I integrate it, I get back to the change in that distance, change in that position. Is that kind of making sense? So this right here represents my speed, or like my velocity function. So if I integrate this velocity or speed equation, you can call it f of x, v of x, speed of x, doesn't really matter, I'll just call it this for now. If I integrate that from 0 to 1.5, are you seeing that? I could use a trapezoidal sum to figure out how far I went. So if that's a velocity equation, I can integrate it and figure out the change in that position. Are y'all seeing that? So how do I integrate it using a trapezoidal sum? So what do I need for a trapezoidal sum? I need 1/2 times the base times what? The sum of the heights, h1, and the sum of the heights would be the velocity 1 plus the velocity 2, or velocity 0 plus velocity 1, but the two individual, I'll call it A and B, right? And I got to keep doing that. Well, if I give you the table, I am forcing your hand on the intervals. I'm saying, there's your first interval, there's your second, third, fourth, fifth, sixth. So I'm going to have 6 trapezoids there. Are you seeing that? And what is the base of each of these?
1/2.
Or
1.5.
Don't do that, because these could be different. It just so happens that 1.5 divided by 6 is a quarter, but a lot of times they won't make these the same. So you look up there and look at them. These indicate your bases. Are you with me on that? And each of those bases happens to be what? 1/4. So I'm going to put a quarter on each of those. 1/2 times the base, right, times the sum of the heights. And the heights are the y values of the function. And the y values of the function are your speeds, or what we're thinking about as velocity. Yes?
So on the AP test, they could conceivably give you a graph with like pre-placed bases and have them be like different.
They will do that, except they normally don't do a graph, they do a table. Like, it is probably more unusual for you to get a table that has bases that are the same. And you can see that, right? That minus that is a quarter. That minus that's a quarter. That minus that's a quarter. But if they give you tables, I would be more under the assumption that they're going to be different. Are you seeing that? Now this is the same, but look at this one. 0 to 1, that's 1 second. The base is 1. But look, 1 to 3, that's 2. 3 to 4 is 1. 4 to 6 is 2. 6 to 7 is 1. 7 to 9 is 2. If I make the mistake of going 9 minus 0 and divide it by the 1, 2, 3, 4, 5, 6 intervals, I'm going to have 1.5, aren't I? And my bases are 1.5. And the problem with bases being 1.5 is I don't know what goes with 1.5. I don't have its y value, do I? So I have to go with what's given to me. Okay? So in this particular case, every base ended up being a 1/4. And I can see that. And because I have the heights right here, I come in here and go, all right, the velocity, which is like my height of my velocity function, 12, 11. And then I go to the next base, 1/2 times a 4th. But this time, what do I use? 11 and 10. Are y'all visualizing this? Because if I were to plot this on a graph, guys, if I were to graph this, I would have a function. This is like my velocity, or call it speed function. If you want to call it speed, that's fine. If I had a speed function over time, I would say, okay, at time 0, at time 1/4. Okay, my speed is 12, so I'm up here at 12 on the first one, and I'm up here at 11 on the second one. And then at 1/2, which is another quarter, I'm up here at 10. And then at 3/4, I'm also up here at 10. So basically, I'm giving you all these little isolated points so that you don't have to plug the number in and find the y value. I'm giving these to you. These are like the y values, the f of x's that we had yesterday. They're just handing them to you. You now have to just plug them into your formula. And on a trapezoidal sum, it would look like this. So 1/2 times a 4th. The next one would be not 11 to 10, but 10 to 10. And then 1/2, 1/4. If you get stuck right in 1/2 and 1/4, 1/8 will do, right? And then 10 and 8. And then 1/2, 1/4, 8 and 7. And then finally 1/2 times 1/4, 7 and 0. And those would be your 6, 2, 3, 4, 5, 6 trapezoids that you would add together and figure out. And if I was doing the math on that, I would probably go, you know what, every one of these has a 1/8 in it. So I'm going to factor out 1/8 out of all of this, just make your life a little bit easier if you're typing all this in your calculator, and then say, okay, that's a 23, that's a 21, the next one's a 20, an 18, a 15, and a 7, and that might make the math a little easier to deal with. Y'all seen it? So that's a trapezoidal sum, and I'm going to get a different answer for this than if I do a midpoint. I'm going to get a different answer for this if I do a left or right. Oh, and by the way, let me talk about a midpoint. AP does midpoints a little weird, and you're going to be bothered by this, okay? But it's easier. So on a midpoint, like say I asked you to do a midpoint on this. If you remember the rule for midpoint, it's what? I really want to do what?
Average the two.
I want to find the x in the middle and plug that in and use that y value. The problem is, I can find the x in the middle of that, it would be 1/8. But I don't know what y value goes with 1/8, do I? So the way AP will do midpoints is they'll do this. I'm going to use that as my base. And the one in the middle, even if it's not perfectly in the middle, like right here, if this was a midpoint, they're going to go, all right, I'm going to do that as the base is 3, and I'm going to use the y value that goes with that middle number, even though it's not even in the middle. 1.5 is in the middle, but it's all I have, right? Because I don't know the y value that goes with 1.5. So I go, well, I'm going to use the y value that goes with this. But it's pretty easy, right? Base 3 times height 7. Base 3 times height 10. Base 3 times height 16. And you just have 3 intervals instead of 6. That's how midpoints would work. And we'll see more of those as well. So if I was doing a midpoint here, I would say base times the height of the number in the middle. That's the middle, so I take the height. And then base, another 1/2, times the height that goes with the middle, right, which would be the 10. And then base, another 1/2, times the height that goes with that middle number x, which would be a 7. So even though it might be annoying and you might be like, I don't really like that at all, I think you should pick halfway in between there. It's because there isn't a y value in your table. And if you're thinking to yourself, well, why don't you just average these y values? Because you don't know. This thing could have gone from 12, to 100 and then back to 11. So you go with what you have and you just say, that's the best I'm going to do. And on the flip side, it is easier. Once you figure it out, it's just less stuff to calculate, right? Right here, this ends up being 14 and I'm done. Move on. Right? Yes? Okay. So anyway, that's what tables look like. I just want to work a little bit more on this for those of you that might be a little bit more, might be struggling a little bit. And if you didn't know how to do these table ones yesterday, if you did, awesome. If you looked at the key and it made sense, super. But if you didn't, super. If you didn't, look at day 2. And let's just get a little bit more practice with some of these different ones. And hopefully you'll be in good shape. So here we go. We got velocity of a car. So velocity of a car is written down at various times. So meters per second. And by the way, be careful also. Every now and then AP will just be a total jerk and switch these up. So people get in this habit of going, oh, the top is always the time, the bottom is always velocity. Or the top is always time, the bottom is always acceleration. Or what some rate is on the bottom. And that's usually true. And every now and then they'll flip them up or they'll give you a vertical column. Just make sure that your bases are coming from the times, and then your rates, or whatever that kind of rate is what your heights will be coming from. So what kind of chart did they tell me to do on the first one? A left hand. Now, if you're having trouble visualizing this, again, remember, these are points on a curve. So just to help you with this one, the points they gave me were at 0, they gave me 4, then they jumped all the way to 12. Then they jumped to 19. Then to 26. So these are irregular. Then to 32. And then to 35. And then the heights at these were at 25. We'll call that 25. At 0. Then at 37. Then at 41, then slightly higher at 42, and then back down a little bit at 40, and then jump back up here at 51, and then at 52. And it'd be very tempting to assume that it's some kind of nice, smooth movement through here. We don't know that. We have no idea how smooth it could. I mean, anything could go. So don't make any assumptions. Just go with what they say. So if I'm doing a left-hand approximation, what are we doing? What would my bases, my first base be?
4.
First base is 4. By the way, just do all the bases real quickly. What would the next base be?
8.
8, and then
7.
another 7, 6, and a 3. So my bases, they forced my hand on it, which again, I don't mind that, but never, and they do that so you can't use these programs that people, granted, there were a lot of programs for 84. People don't use 84s a ton anymore. Some people have them, but there were a lot of programs you could download, but they're not going to work as soon as I change the bases up. Don't make the mistake of going 35 minus 0 divided by 6. Don't do that. They're dictating the basis to you. The only time you take ending minus beginning and divided by the number of whatever we're talking about, rectangles, the only time you do that is when you have a function and you just have to figure out basis. There's no other way you could do it. Okay, so on a left-hand approximation, what am I doing? I'm bringing up that base until what? The left side hits. So on the left hand, I'm going to be using base 4. So how do I write this? The integral, and again, if it's a velocity function, v of t dt, from what to what? 0 to 35, and I'm going to say is approximated, and then I'm going to start the process of base height, base height, base height. So first base is 4. AP wants to see that, and the first height would be 25. Literally, they want to see this right here. Next base is 8, and it's going to go up. If I bring up that, it goes up until the left side hits 37. Next base is
7,
and it goes up until
41,
the 41. Next base is
7,
and it goes up until the 42. Next base is
6,
goes up to the,
40,
and then the last base is 3, and it goes up to the 51. So I hope you're not even thinking about this picture in the future. I hope you do this. Okay, 4 left, just visualize, I'm using the 25. Then 8, I'm visualizing the left side 37. 7, choosing the left side 41. 7, choosing the 42. 6, choosing the 40. And 3, choosing the 51. And if you're visualizing it that way, you don't have to draw this picture and waste all that extra time. And then you type in your calculator, it spits out 22.917. So AP would have given you, that's not right.
18 points.
What did oh, I have a different problem here.
Oh no.
Well, forget my problem. Based on this, it's not that, because there are no decimals here, but it's some number. Are you with me? So you would get 1 point for the setup, for that setup, and then 1 point for your answer. Are y'all seeing this? Okay, what about midpoint? What's a midpoint going to do? Now remember, on a midpoint, what I really want to do is find the number in between that and go with the value that it's with. But I don't know the y value that goes with 2. I don't know the y value that goes with 7, which is dead in the middle, do I? So what I'm forced to do, again, I don't need this picture. I'm going to skip a value so that that number in the middle, I can use its y value. I can use its y value. Even though it's not dead in the middle, not even close sometimes. I mean, this 32 is 3 away from that and 6 away from that. That is not the middle, but that's the best I have according to APCalc. So whether that makes sense to you or not, or you agree with it, is not really a matter of debate. It's just a matter of doing what they want you to do. When in Rome, do as the Romans, right? So, but I like it because I only have to do 3 intervals. So right here, if I'm approximating, and again, this is for midpoint, so I'm doing this one right here. I'm going to take the base, which is now what? 12. I'll put it right here. And then what would the height that goes with that 12 be? 37. And then I'm going to take the base, which is now 14. And then the height would be 42. And then finally the base, which is 9. And the height that goes with that point, 51. And that would be a midpoint Riemann sum. And then the last one I want to talk about on this would be the trapezoidal. Now trapezoidal, what am I really doing? 1/2 times the base times the sum of the heights on either side. So on this one, I'm going to go back to my original bases. And we did this already, right? That's base 4, 8, 7, 7, 6, 3. So I'm going to say, so this is for trapezoidal. For trapezoidal, I'm writing it right here. So integrate the velocity dt from 0 to 35. And I'm going to approximate that by 1/2 times the base, which is 4, times what? 25 and 37. And I'm going to be honest with you, I personally would write out 25 and 37 and not write 62, because if you accidentally add 25 and 37 incorrectly, then you don't get the credit for that full point. Show your work on this. All right, now I'm going to be writing 1/2. Notice it's not going to always be 2, is it? Because my base is changing. So 1/2, next base is 8. And what are the sums of the two heights in that? 37 and 41. And then 1/2, next base is 7. Two heights, 41 and 42. 1/2, another 7, 42 and 40. 1/2 and 6, 40 and 51. And then finally 1/2 and 3, 51 and 52. Y'all see it? And that's the trapezoidal sum. And again, most people do really well on this, but AP gives you 1 point for the setup and then 1 point for the answer. And they're not going to give you something like this without a calculator. They're just not. If they give you something without a calculator, it might have 4, and then probably the bases will work out pretty nicely. Rarely, if ever, have I found myself without a calculator looking at a problem going, you've got to be kidding me, and being that frustrated about the math. I'm not saying that you might not be on your homework, but on your homework, you got a calculator. But on the AP test, it usually is a matter of showing your setup. The calculations are minimal at best. They're not, it's like taking the PSAT, if you remember that. You had a calculator there to maybe help with some simple math, but you really didn't need it. And it's kind of like that with the non-calculated part. It's not that big of a deal. All right, what about, so like this is one where they actually give you the function. And when I'm giving you the function now, everybody has this, right? When I'm giving you the function, to me, it's a little more work. And this is where, George, when you don't have those when you don't have those preset bases, then what you do is actually figure that base out based on where you're beginning and where you're ending. So where am I beginning and ending on this?
1 and 1.
Okay, so if I have that function, I want to integrate that y, and normally they'll say let y equals f of x. So I can say the integral of f of x dx from 1 to 9, right? And I'm doing a right-hand Riemann. So I need to figure out the base first. And the base is what? 9 minus 1 over how many rectangles? 4. So 8 over 4 is 2. So I know my base is 2 each time. So how am I going to do that? I'm going to have 4 bases. Now, if I'm doing a right-hand Riemann, visualize this with me. Say here's your function, right? And you're going from 1 to 9, and you have 4 rectangles. If the base is 2, those are the interval locations, right? For a right-handed Riemann, I'm always going to use the base that's 2, but for the height, do I plug in f of 1 to find that height? No, because if I use f of 1, that means I'm bringing up the left side's height. So on a right Riemann, I want to start with f of what? Not 1, but 1 base to the right of the 1, which is add 2 to that. I want the f of 3. And what is f of 3 based on this? 11. And what AP wants to see is that 11. They don't need you to write f of 3, but I'm just showing you the math right now. On a chart, you would just have that. Here, you had to find it. All right, next base. Still the base is 2. What is the next height I'm needing to find. The height at what? 2 more, 1 base past the 3, which would be f of 5. And what does f of 5 give me? 27. And then the next one will be base times f of 7, which gives me 51. And then finally, f of 9, which puts you at the far right side. So you're already there, which is what, 83? And then when you multiply those 4 and add them all together, that's what you would get your final point for. So a point for the setup, point for the answer. And I know that seems a little unfair, like really 1 point for the setup, 1 for the answer. But again, if you get 1 out of every 2 points, you've made a 4 on your AP test. 54 out of 108, which is almost always a 4. Sometimes it might be a little lower, occasionally maybe 55 or 56, but usually that's the cutoff. So if you show the setup, you're in pretty good shape, even if you did miss that. Although hopefully you won't. On a midpoint, see on this one, I'm not going to go skipping values, am I? If I want 4 intervals, those are my 4 intervals, but I don't need to skip from 1 to 5 and 5 have the function.
Yeah.
I mean, yeah.
Oh, sorry, I missed that. So from 2 to 6. So from 2 to 6, I'm actually doing that. Sorry, I need to pay attention. And it says use 4 rectangles. So 2, 3, 4, 5, 6. It makes it a little uglier. I don't know why I did that. But so now to do a midpoint from 2 to 6, I'm going to say, all right, from 2 to 6, f of x dx is approximated by a midpoint. Now, from 2 to 6, that makes each base have a length of what? 1. So each base, 6 minus 2 over 4 is 1. Each base is 1, but the height, I'm not going to use 2, 3, 4, 5, and 6. What am I going to be using? That's right. So I'm going to be using 2.5 to bring that middle up and find the height. So don't write times 2.5. Remember, we're finding the height at 2.5. So what do I have? Base is 1. What is the height at 2.5? What's 25 squared?
8.25. That's 6.25.
Plus 2? Good, 8.25. And then the next base is also 1, but I'm going to use f of what? 3.5. What's 3.5 squared?
12.25.
12.25, I'm taking your word for it. Plus 2?
14.25.
14.25. And again, I'm not doing this to you on a test unless you had a calculator. Even if you had a calculator, I probably would. And then the next one, base times 4.5, and then finally base times f of 5.5. And yes, that's a little bit of a pain. No, I would not do this to you without a calculator. What's 45 times 45? 2025. So plus 2. So 22.25. And then last one, have you already done it?
It's 32.25.
32.25. So you're actually squaring them and adding 2 for each of those, and then you go through and add this up. Did you get 77?
I have that.
Yeah.
Okay. Are you seeing this? Guys, these are all over the AP test. The only thing for you is understanding when you're going to be doing it, but usually it's really clear because they'll say, using a right-handed approximation or a left-handed approximation or a midpoint or a trapezoidal, and then boom, you're like, oh, write the integral, write that out, put a little approximation sign, and then start the process. And really, it's the same thing over and over. And I got to be honest with you, they don't give you a function as much as you would think. Most of the time, they give you tables. Occasionally, they give you a function, but most of the time, they give you tables, and you're using the table to approximate. So you don't even have to go through the pain and suffering of actually plugging junk in. But you'll definitely see both on this test. And then trapezoidal, says 4 trapezoids on the interval from 3 to 5.
Whose one is that?
So 3 to 5. So trapezoid 3 to 5, f of x dx. So I have 4. So the base is 5 minus 3 over 4. So the base is a half, right? So for a trapezoid, what am I doing? 1/2 times the base, right? Times what? The sum of the two heights. What's the first height? The height at 3, f of 3. What's the next height? F of 3.5, because the base was a half. So f of 3.5, which is annoying because I have to plug both those values in there, but we've already done 3.5, right? So that shouldn't be that awful. I'm not going to actually do the math on that. And then the next one, 1/2 times the base again. And what was going to be the heights on this one?
F of 3.5.
F of 3.5 and
F of 4.
f of 4. And then 1/2 times the base times
F of 4.
f of 4 and f of 4.5. And then finally 1/2 times the base times
4.5.
f of 4.5 and f of 5. And honestly, if your base is the same, most people, and AP is totally fine with this, would write this. They would write 1/2 times 1/2. And then they actually do this. Once I take out all the 1/2s, check this out. Once I factor out all the 1/2s, what do I have left? And I'm not going to encourage you to do this, but some of you are going to like this. What do I end up with? 1 f of 3, and then what? 2 of those, 2 of those, 2 of those, and then finally 1 at the end. And that's a formula you see in most textbooks, but I don't encourage it. I actually took it out of mine. I think it's actually in your notes, but I've taken it out because usually it doesn't save you that much time. It's one more thing you have to try to memorize. But in terms of typing in your calculator, it might save you a little time. Like for instance, if you found that f of 3 was, what is it, 9, 11? And what's f of 3.5 again? Anybody? 14.25. So that happened twice. And then f of 4 is 18. That happened twice. And what was f of 4.5? 22.25. That happened twice. And then f of 5 would be 27. So you can see the calculations would be kind of tedious. But if I came down here and went, okay, that's an 11. And then I'm just going to go 2 times the 14.25. And then I'm going to go 2 times the 18. And then I'm going to go 2 times the 22.25. And then I'm going to go 27. And the math of it just ends up being a little bit easier if you happen to know that. But when can I can only do this when what? When my bases are the same. Otherwise, you're just stuck with this original formula. So that's why I just rarely do you have the bases the same on something like that. It'll happen on my test probably, but usually I only have like 4 rectangles or 4 trapezoids. So to me, it's not worth the mental brain cells until you get to maybe a college class where you have 18 trapezoids. And then you're like, crap, it might be nice to actually have a way to get this done a little bit more quickly. What do you think? Y'all liking some Riemann Sums? Woo-hoo.
That would be great.
Good.
Are there other ones besides left, right, center, and trapezoid?
Not that I know of, and not that you would ever need to know an APCalc. But I mean, I'm sure you could do like with many triangles, with circles. I mean, they're just not going to be better. Really, the best way to do it is just to fit shapes in there. I mean, when you need a rectangle, use a rectangle. When you need a triangle, use a triangle. When you need a circle. But as far as a formal method of doing it, those are what Riemann came up with. And keep in mind that what Riemann plans on doing, or at least what Newton did with Riemann Sums, is he's taking these rectangles and shrinking them down and making more and more occur. So it's almost like having sheets of paper in there. So when you shrink a rectangle so thin that it's almost like a line, then I can fit lines under there perfectly, can't I? So the idea is the base goes to 0 and the number of rectangles goes to infinity. Now I have a sum of an infinite number of rectangles whose limit of their base goes to 0, and that's what's going to end up being our actual integration formula. And there's ways to go about doing it. Actually, those of you that had me last year, do you remember those horrible formulas I made y'all memorize that were like the sum of the first 30 squares, the sum of the first 30 cubes?
Yeah, I don't actually remember.
Okay, well, yeah, I know, exactly. Yeah, well, those are formulas you can use to do giant summations. And we did that. It was kind of a pre-cal topic. Well, you can use those same formulas to actually determine integrals, right? But we got rules for integrals, right? So we don't need to. Well, we got a lot of them. There's plenty more if you take Cal 2, Cal 3, whatever. But we already have enough to integrate officially. So what we're going to do is understand the y of the integral, but we're never going to use that limit formula that has you'll see, that's awful. It's easy to work with, I think, but it's awful looking to evaluate. It's got a limit and a sigma notation and it's all kinds of garbage going on in there. But the idea of it takes these Riemanns, and when you make a rectangle or a trapezoid or a midpoint so skinny it looks like a line, it doesn't matter which one of these you use. It'll always find the exact integral through that process. So anyway, even though you might think this is a little silly and maybe a little rudimentary, and I would probably agree with you, it's something on the AP test, and it accounts for a decent amount of material. And the upside is not too bad. You know, I think it's kind of easy in the whole scheme of things because there's not like any way I can really mess with you. But what you need to understand is, what did I just find here? If I integrated some kind of rate, what did I find? A change in the amount. If I integrate gallons per minute, I found a change in the number of gallons, not how many gallons. When I integrate, when you're in AP physics and you do a definite integral from 2 to 10, you didn't find out how much, you found a change in how much. That's what you're finding. If you really want to know how much you have, you got to know where you began, right? If I want to know where I'm located, I got to know where I'm starting. If I want to know how many gallons are in my pool, I got to know how many were there before I started pumping it in. But the integral helps you do that. And that's all I have for you. So if you want to look at day 2, I think that's all I have are these 4 problems for you. Although there are some part A, part Bs. So if you want to get started on your homework, if you have any particular questions, feel free to ask me. But this should put us in pretty good shape. And tomorrow we'll jump into something new. All right?